So this lesson will be about applying Ohm's law to alternating current circuit. The first device we are going to study is a resistor, pure resistance in a AC circuit. So this is a resistor. This resistor is connected to an AC generator whose potential difference equation is changing by V is equal to Vm sine omega t. And a voltmeter is connected in parallel with the resistor, and an ammeter is connected in series with the resistor, so we can measure the electric current on the resistor and potential difference between the ends of the resistor. By these two devices, we can calculate potential difference VR across the resistor and electric current IR through the resistor by using these two devices. First, we should define what does pure resistor mean. So a pure resistor is a resistor with no self-induction. So this is the key. So then it must be a conductor, but this conductor will have no self-induction, which means L is going to be 0. So, in fact, what resistance means, it's explained in the 11th grade. Remember, when the electrons are moving through a conductor, they collide with the atoms, and then this collision of electrons with the atoms results in the resistance. So the conductor resists the flow of electric current. So it's defined as resistance. This phenomenon is defined as resistance. And you also learn that the resistance of a pure resistor depends on three things. One of them is length. If a conductor is longer, so its resistance becomes greater. So longer wire has a greater resistance, directly proportional. You learned in the 11th grade. Second one is the cross-section area, thickness. So if the cross-section area, which is thickness, is big, so resistance becomes small. So it becomes easy for electrons to move if it is a thicker wire. And then third factor is the type of the conductor. So copper is a good conductor, silver is the best conductor, aluminum is the third best conductor, and so on. It's going like this. So type of the conductor also affects the resistance. These three factors determines the resistance of a conductor. So you can calculate the resistance of this conductor by length, cross-section, and type of the conductor. These three determines and gives this resistor as a number. This resistor can have a resistance which is equal to, for example, let me give a number, random number, 100 ohm. So this 100 ohm belongs to that conductor. But resistor of a conductor can be changed by one more phenomenon, which is the temperature. If temperature of the conductor increases, also you'll learn that, the same conductor can have a resistance which is maybe 101 ohm. So high temperature. If you decrease the temperature of the conductor, in this case you get a temperature of resistor 99 ohm. So resistance of this conductor, specific conductor, can change by temperature. So this is the only thing which can change the resistance of a conductor. And resistance can be changed only with the temperature for a specific resistor. Why I explain this? Because we will learn that in the coming titles. So changing the frequency of alternating current can change some quantities, but changing the frequency of alternating current cannot change the resistance of this resistor, because the resistor of a conductor is constant. Only temperature can increase or decrease the resistance of a specific conductor. So now let's continue with the title. This part was the 11th grade part, but which is maybe could be better for understanding this title. That's why I explained them. So resistance of a conductor depends on what? Length, area, and type. And when you make a resistor from this conductor, then one more quantity can change that resistance, which is the temperature. So according to Ohm's law, electric current and potential difference proportionally change in a resistor. What is Ohm's law? V is equal to I times R, which means because R is constant, only changes with temperature. If you don't change the temperature, R of a conductor stays constant. If electric current is increasing, which means proportionally potential difference across the resistor must increase. If electric current is decreasing, so the potential difference across the conductor resistor must decrease. If electric current is zero, potential difference must be zero. So this says that this reading of ammeter and voltmeter proportionally changes. Yani reading of the ammeter and voltmeter increases, decreases, or becomes zero together simultaneously at the same time. Yani if the reading of ammeter and voltmeter is changing proportionally, this fact in alternating current is defined as being in phase. Yani electric current and potential difference are changing proportionally, so that this fact is explained by being in phase. A good example, look at this graph. So this blue line is representing the current, alternating current. The red line is representing the alternating potential difference. As you see, when electric current is zero, potential difference is zero. When electric current is increasing, potential difference also increases. When electric current gets its maximum value, potential difference also gets its maximum value. When electric current is decreasing, potential difference also decreases. When electric current becomes zero, potential difference also becomes zero. So this fact, this change, proportional change in electric current potential difference in an alternating current is explained as the fact being in phase. So then we explain it like this. In a pure resistor, electric current IR on the which ammeter reads, potential difference VR, which voltmeter reads, are in phase. They have equal phases, omega t. So then, look at the equation for potential difference. VR is equal to Vm sine omega t. IR is equal to Im sine omega t, which means their phases are equal. Both potential difference and electric current has the same phase, which is omega t. Okay, and being in phase in this graph also can be represented by two vectors which are in the same direction, which is called phasor. Remember, if there is no difference in angle, which means two vectors are in the same direction, angle between them is zero. Look at this one. IR is the electric current. VR is the potential difference across the resistor. So then as you see, these two vectors are in the same direction. Angle between them is zero. And they are in phase. These two vectors representing parallel vectors, which are in the same direction, representing electric current and potential difference across a resistor are in phase. So the curves of current and potential difference for an ohmic resistor, when it says ohmic, you should understand it is pure resistor. Ohmic resistor means pure. Is sinusoidal, yani changing as a sine graph, both current and potential difference, alternating potential difference, changing as a sine graph. Sinusoidal means this. And omega t is the phase of both potential difference and electric current together. And resistance of a pure resistor is measured equal in both DC and AC, which means we can use Ohm's law for calculating resistance in DC or in AC. Yani, so if you divide instantaneous potential difference VR by instantaneous current IR, or you can write their equations. Vm sine omega t is the instantaneous potential difference. Im sine omega t is the instantaneous electric current. If omega t sine omega t is simplified, so Vm over Im also gives the resistance of that resistor. If you divide this Vm by root of 2, you calculate V effective. If you divide this Im by root of 2, you calculate effective current. Again, Ve over Ie will also give us the resistance of this conductor. So then we can use these three equations, but most probably we'll use these two. And Vm over Im is equal to resistance. Also, Ve over Ie equals to resistance of that conductor. Change in frequency of the AC does not change the resistance of per resistor. I just explained that. Resistance only changes with temperature. Nothing else can change the resistance of a conductor. For that reason, if you increase the frequency of the generator here from, say that, from 6 to 200 hertz, so resistance of the resistor does not change. It is independent of frequency. So resistance of a resistor in an AC circuit is independent of frequency. This is a very important fact, asked maybe twice or three times in ministry exams. And this is all about how we define the resistor in AC circuit. Now we will solve some problems about this. So the first problem is a sample problem. It says that an electric heater operates under a potential difference of maximum value 282.8 volts. So the given maximum potential difference is 282.8 volt. If the resistance of the heater is 500 ohm, of course resistance is represented by R, 500 ohm. What is the effective value of the current? Calculate IE. Effective value of the current. Calculate the generated heat energy if the current runs in the heater for half an hour. So time is 30 minutes. Half an hour means 30 minutes. Of course, we should convert this to the second by multiplying 60. 30 multiplied by 60, which is 1,800 seconds. So calculate the energy given out during this time interval. So let's calculate first effective current. We have to find that. But to calculate effective current, we need to convert maximum potential difference to effective potential difference, because we know that Ohm's law can be used like this. R is equal to Vm over Im, or R is equal to Ve over Ie. So we should use one of them to get the effective electric current. So then that's why we need to first calculate what effective value is. So let's calculate effective value. So V effective is equal to, we know that, V maximum divided by root of 2. V maximum is 282.8 volt divided by root of 2. Let's use the calculator for this. 282.8 divided by root of 2 is equal to almost 200 volt. 200 volt is the effective potential difference. So then we can now find what IE is, cross product. So IE is equal to VE divided by R. So then VE, we just calculated 200 volt divided by R. R is given as 500, so which is equal to 2 over 5, just 0.4 ampere is the effective electric current of the circuit. So this is the first part. Second part is calculate the generated energy if the current runs half an hour, 30 minutes, which is 1,800 seconds. So then we can use energy equation. Remember, power is equal to energy divided by time. Everybody must remember, this is the general definition of power for all types of power, not only for electrical power, wave power, mechanical power. All it's calculated like this. But here I'm going to use the electrical power equation, because electrical power is equal to I effective squared multiplied by R. This is the electrical power. Delta E divided by delta T. Questions calculate what delta E is. We will find that. So cross product again. Delta E, which is the electrical energy given out by the heater, is equal to I effective squared R multiplied by delta T. Given what is I effective given, how much is it? We just calculated it, which is 0.4. 0.4 squared multiplied by resistance is 500 ohm multiplied by time is 1800 second. If you multiply them all, you will get 144,000 joule. And if you want to convert this to kilojoule, you should divide it by 2, by 1000. If you divide them by 1000, you can convert it to kilojoule, which is equal to 144 kilojoule. This is the maybe 2 or 3 times asking this exam question. So 144 kilojoule is the energy given out by the heater in half an hour. Next question is a practice problem 1. A resistor of resistance 20 ohm, so R is equal to 20 ohm, is connected across an AC source of effective value. AC source effective value 10 volt, which is of course potential difference. Effective potential difference is 10 volt. Calculate maximum and effective values of the current. So, of course, effective potential difference is given. Better to calculate first effective current. After that, calculate maximum current in the resistor. So Ohm's law, so if we know R and V, and you can calculate I, so we know that I is equal to VE divided by R is the equation. So now let's calculate what effective current is. Effective potential difference is 10. Effective resistance is 20. 10 over 20, which is 0.5 ampere, is the effective current. And now we are ready for finding the effective maximum current, because we know that maximum current is effective current multiplied by root of 2. So then maximum current is going to be 0.5 multiplied by root of 2. You can leave like this, or you can find it by calculating your calculator. 0.707 ampere is the maximum current. And the next question, question number 2, it's asking if the frequency of the source in item 1, when it's talking about item 1, it's talking about the question number 1, frequency is 50 hertz, which is F is equal to 50 hertz. Write down the expression of the instantaneous current and instantaneous potential difference across the resistor. So equation for instantaneous current potential difference, remember electric current potential difference are in phase. They will be like this. IR is instantaneous current. Im times sine omega t. This was the equation for instantaneous electric current. And potential difference will be in phase with the electric current. They will have the same phase angle. Vm sine omega t. Write down the expression of the instantaneous current potential difference means insert those constants which are Vm, omega, and Im. We will calculate them and insert these constants into the equations, so then we will finish the answer in the part A. So Im, we calculated it in the question number 1. That's why I am going to record it here, which is 0.707. We need to know what omega is. Omega is, can be calculated by 2 pi f. So let's calculate it. Omega, because we need to write it here. Omega 2 pi f is 50. So it's given the question, which is 100 pi. Generally, in these types of question, leave omega by pi, 100 pi radian per second. So we got the second constant. First constant was Im. Second constant is omega. Third constant is Vm. Now let's calculate Vm. If we know Im, we can calculate Vm, because we know that Vm is equal to Ohm's law, Im multiplied by R. So Im is 0.707. R is in the question. The first question is given as 20. If you multiply this, 0.707 multiplied by, let's calculate it. So 0.707 multiplied by 20, which is 14.14. 14.14 volt is the maximum potential difference, which is third constant. Now, after that, we are going to insert the constant into the equations. Expression for electric current IR is equal to Im. What is Im? 0.707. This is constant of maximum value. Sine omega is how much? Which is 100 pi. What is variable? T. T is variable. And for potential difference, VR is equal to what is Vm? 14.14 sine, again, omega T. Omega is 100 pi T. So this is the expression for potential difference. This expression for instantaneous electric current. By the time these values are called instantaneous potential difference and electric current, which means they change with respect to time. As time changes, instantaneous electric current and instantaneous potential difference changes. And here also, third question, calculate energy dissipated in the resistor during 5 minutes. It's the same as this one, the same method of the sample problem one. First, you are going to convert this 5 minutes into seconds. Then I effective square times R multiplied by delta T, again, will give you the energy dissipated in the resistor during 5 minutes. So this part was about the pure resistor, and then next lesson we will study pure inductor, pure coil in the alternating current circuit.